Hi there, everyone. Welcome back. If you joined me for the previous three questions, you're going to love this question. We're going to be handling question number 4 from the 2012 Csmc. That's the senior contest, so grade 11-12 work. Fortunately, we're still in part A, as we can see. So we just need the written answer. Okay, question number 4. Let's take a look at it. 3 boxes each contain an equal number of hockey pucks. Each puck is either black or gold. All 40 of the black pucks and exactly 1/7 of the gold pucks are contained in one of the 3 boxes. Determine the total number of gold hockey pucks. So it's a fun little question. Hockey pucks, I'm guessing they added that because it's a Canadian contest. And for those in the know, I believe black and gold are the University of Waterloo's school colors. The University of Waterloo is where the Csmc is based. So it's a nice little in-joke, in-reference question. Okay, so what have we got? We got 3 boxes. They all contain the same number of hockey pucks. We are given the distribution, like we know all the black pucks are in one box, and that 1/7 of the gold pucks are contained in the other boxes, or in that box. So we need to sort of set up an equation to tell us, well, how many gold pucks are in the other boxes. And then from there figure out how many gold pucks. That's the total we need. We need the total number of gold pucks. Okay. So we got ourselves our paper here. So we can draw ourselves a little picture. Get 3 boxes. So you can say box A, box B, box C. I don't know if we'll need these labels, but we'll say this is the first one. It's got 40 black. Plus 1/7 of the gold. So we need to figure out, well, there's no black pucks in B or C because they said all the black pucks are in the first box A. Alright. So B and C must contain only gold pucks. And since all boxes contain the same number of pucks, so how many can B and C contain? Well, they have to split the remaining gold pucks evenly. So they split evenly. So that's what this 1/2 is. We're dividing the remaining gold pucks in half. We don't know how many gold pucks there are to begin with. We only have this ratio. We know that 1/7 of them are in A. So 1 minus 1/7, there's 6/7 of the gold pucks left. We have to split that evenly between B and C. So that's 1/2 times 6/7. So 3/7 of the gold pucks. If you wanted to, you probably could have introduced let G, capital G, be the number of gold pucks. Then you'd have 40 black plus 1/7 G. In fact, how about we do that now? Actually, let's make it a lowercase g because otherwise it's going to start looking like 6s because I am a terrible writer. So we'll make it a lowercase g as though it were the gravity symbol. So we close up our boxes here and we will write a little statement. So we let G be the number of gold pucks, so now we just need to figure out what G is. That shouldn't be too difficult. Alright. So we could put 3/7 G here and 3/7 G here. But we know that A and B also have to contain the same number of pucks. So we have 3/7 G, the number of pucks in B, is equal to the number of pucks in A, which is 40 black pucks plus 1/7 of the gold pucks. Well, we can rearrange that. 2/7 G, so we bring over the 1/7, subtract it off from the 3/7. So that's equal to 40. So G is 40 times 7/2. We want to cancel out this 2/7 of G. We want to just be left with G, the total number. So we need to multiply by the reciprocal of 2/7, so that's 7/2. And that turns out to be 7 times 20. And you can either do that in your head or on your calculator. You get 140. So we get 140 gold pucks. Okay, and if we wanted to, we could double check that. We could say, okay, well, if that's the total number of gold pucks, if that's G, what's 1/7 of G? Well, that's 20. 40 black pucks plus 20 gold pucks should be equal to 3/7 of 140. Well, what's 3/7 of 140? That's 3 times 20, that's 60. 60 is indeed equal to 40 plus 20. So we do have the correct number of pucks in each box. So that's just a little check we can perform if we want to. If not, if we're confident in our answer, that's okay. It's a written question. We just need the 140. And I think you just put it in a little box next to a light bulb. It's been a while since I took a look at the answer booklets for these contests. But regardless, you just put it in the designated area. You just need final answer. But if you want to check, you can go back and check that your numbers make sense and that the boxes all have equal number of pucks. And that concludes question number 4. It's a nice little question, as I already remarked. If you're in the know, you can see little Canadian things or little Waterloo things every once in a while in these contests, which is quite nice. But, yeah, good question. Good question. And I hope question number 5, which we'll see in the next video, is just as good. So, as usual, thank you so much for watching, and I'll see you guys next time.